Welcome back to It Depends. After spending his entire career at the center of how the world stores, moves, and makes sense of data, my guest today is now helping decide what that looks like in the AI era. Sailesh Krishnamurthy is Vice President of Engineering at Google Cloud, where he leads engineering for the entire database portfolio. More than 25 years in database and the cloud. Before Google, he ran Amazon Aurora, RDS MySQL, and before that, he had founded his own company called TrueViso, a real-time streaming analytics, another hot topic these days. That company was acquired by Cisco. He has PhD in computer science from UC Berkeley. He's authored dozens of academic papers, several US patents. These days, his focus has shifted to how data infrastructure is morphing in the era of AI agents and for example, embedding models, frontier models inside database, making databases more friendly to agents. So we have a lot of topics to parse. Sailesh is a good friend of mine. I am so honored, Sailesh, you took time to come to the podcast.
Thank you so much, Sanjeev. Pleasure is mine, and I always enjoy our chats.
Thank you so much. So I learn a lot from Sailesh anytime I'm working on any new project. For example, Sailesh, this may remind you, I reached out to you when I was starting to write my new book called Designing the AI-Driven Data Foundations. So that book is now done. It's in print right now, and it should be available in the next few weeks or so. So thank you so much for all your help.
Congratulations! I should order a copy right away.
I there is a pre-order link. It's on my website. I should do a better job of marketing, but anyway, that's not what we are talking about. We are so I gave a very brief introduction of you. Can you tell us more about what's your background and what is the role that you have currently at Google Cloud?
Yeah, so as you said, I've been in the database business for a long time. I started working on enterprise databases. I worked on DB2 in the mid 90s. Now I work at Google Cloud, where I lead engineering for all our transactional databases or operational databases.
Hmm.
I like to say I have two jobs at Google. One is for Google Cloud. These are our operational databases that Google Cloud customers use. But I have a second job. My team also supports all of Google internally, where their operational data estate runs either on Spanner or on Bigtable. And so, in many ways, my second job is a lot like uh, customers of the first job, where we run the infrastructure and various businesses, YouTube, Gemini, Gmail, search, they all rely on that very same infrastructure to operate all of Google's many billion users, and I think now almost 2 billion plus users uh,
That
systems.
is phenomenal. So Salesh, before we get into databases, we all use YouTube. I remember when YouTube had first come out, even before Google bought, it was famous for its highly sharded MySQL database.
That's right.
What is the what database does does YouTube use now?
Primarily Spanner. You're talking, I believe, about Vitess. I think
Yes,
YouTube had
Vitesse.
built this
Correct.
thing called Vitess and open sourced
Yeah.
it. Uh,
Yes.
the migration to Spanner happened. I don't recall exactly when. Maybe it a significant part of it had already been done 6 7
Hmm.
years back. But it's not just one database in each of these systems.
Hmm.
YouTube has the primary backend database. There's something called a watch history system. There's a whole set of different systems. Most of them run on some combination of Spanner and some Bigtable, but there are also analytics systems, as you might imagine,
Yeah.
inside Google, which are key for all of these systems.
Amazing. So the world of databases is changing pretty rapidly. We are recording this literally days after I came back from the Databricks Data and AI Summit, where a very big part of announcement was this decoupled Postgres database, which Databricks bought from Neon. but then, and they call it lake base. But now what they're saying is that why have OLTP and OLAP databases, just merge it all into lake base, what they're calling LTAP, instead of HTAP. And so hybrid transactional analytical processing, they're calling it lake transactional analytical processing, or LTAP. So, can you walk us through what is happening in the world of databases? What are the customers asking, and how is this space changing?
Right. So I think there are many different things here to unpack. Let's start with maybe the specific topic, and then I'll broaden it out with what's going on in AI. If you leave aside technology and how things are built, uh, and just think about use cases, for example, operational databases, transactional databases are primarily serving applications, and they serve users of applications. But and so primarily they present a user view, and
Yeah.
characteristics of these user view is that it's on the latest data. There's heavy reads and writes. uh, each user's access is mediated by security. Users should only see their information, and few things that are particularly important: high QPS, lots of concurrent users, very low latency. So these are things that we have always expected. But I think it's also true, and it's always been true. So it's not, I think, new at all because of AI. It's always been true that just a few milliseconds after a transactional application comes online, people want to ask questions about it. So I think
Yeah.
of this as the admin view. For
Mhm.
example, you might have a call center application. You have users who make phone calls. You may have representatives who are being assigned to these phone calls, but there's always an administrator, a manager, who perhaps wants to know what's at any point of time, what's the average user's current wait time? Are there many representatives sitting idle? So there's always been the need for this admin view. And if you have that data that is in your transactional system, there's always also been the aspiration of, hey, can I run analytics queries on top of those systems? And
Yeah.
it is historically hard to do this. And many people built different technologies. As you point out, HTAP was one category of these technologies. And generally, a lot of this started off with the idea that, well, if I can organize the data in not just in a write optimized row major format, but also in a columnar format, then I can run analytics queries also on it. But one tricky part for this was it was not just about performance. It was, certainly possible to address the performance challenge, with some work, but it was also isolation. And
Hmm.
isolation is perhaps the most important challenge because the transactional database is serving your line of business application. But if you want to ask any kind of analytics queries, they typically tend to be batch scans. You need to protect your transactional database. So, for both of these problems, Google has been working on this and has had this in production for a long time now, both internally and outside. In AlloyDB, we had a columnar representation of the data to allow 100x performance for analytics queries right on your transactional database right away. And Spanner recently launched a columnar representation too for very similar performance gains. Spanner and Bigtable also have what we call Data Boost, which leverages Google's groundbreaking storage system, Colossus. So we have a truly decoupled compute and storage separation. And in the Spanner and in fact in the Bigtable environment, you can come to storage directly from the backdoor and run any batch scans you want, any kind of analytics query you want, without even having the least bit of impact on your transactional systems. So what I'd like to say is both of these problems, how do you get performance without having to move the data out? And how do you get isolation? These are not new problems. We've had them in production, customers love them and use them.
So what I'm hearing is that the couple of things that customers want, even from good design practices. So a single copy of data instead of having silos of data, but then doing an isolation in a way that on that single copy of data, I can run my transactional workloads, analytical workloads, even streaming workloads without affecting the other one. So basically, to if I were to summarize it, is single copy of data, multiple use cases, different personas, all working against the same copy of data.
I think that's exactly right. I will say that you can think of this
Hmm.
as two ways of looking at the problems, right? If I have multiple kinds of systems specialized, in the end of the day, there are analytics systems which are specialized in certain kinds of characteristics.
Yeah.
Uh, uh, Extreme parallelism, transactional systems are try to solve different problems. You can look at data access in two ways: federation and
Yeah.
replication, and they are duals of each other. And you can replicate from your historically, you could replicate from your transactional system with ETL. You could also replicate from your analytics system back to the transactional system to get the latest insights. But you could
Yep.
also federate. You could ask your
Yep.
questions without moving the data. I think there's space for all of these. And one of the reasons why I will say there's still space to move the data is because sometimes the way you're organizing your transactional data is going to be different. The schemas are different. So, in other words, the analytic schema is not necessarily going to be a facsimile copy of the transactional schema. Let me
Yeah.
give a very
We
simple
have. Yeah.
example. You have
Yeah.
a distribution center for a logistics company. It's organizing the data around answering the question of what item, what SKU is present right now. Whereas the analytics system, you want to know the whole history of SKUs and items in the particular distribution center. So I think there's always a space for that
Yeah.
as well. But you should not need to do it, is perhaps my.
Correct. Yes. So the whole idea that the only option was to do ETL. Now there are many other options. So you can do ETL and or ELT. You can do a materialized view with change data capture and refresh,
Sure.
or you can do federation, what we are now calling zero copy. So
Right.
you can, with faster networks that we have and co-located, like Google Cloud is co-located with other hyperscalers. So you can even do real-time stitching of data using zero copy techniques like push down, caching, and all of that. So there's a lot of choices now in this world.
That's right. And I think choice is a key piece. It's a key part of our
Yeah,
agentic data cloud strategy.
yeah,
The first is, of course, all about uh, making sure you're building AI native infrastructure. And there's a lot to talk about there, which maybe we can come at
yeah.
things like graph processing and vector indexing, things like that.
So,
This,
yeah,
the second is all about openness. And I think one thing that we've certainly learned is customers have very diverse infrastructure. They don't just use one hyperscaler. So
yeah.
uh, connectivity is important, but we've also brought our transactional databases to run in other environments, other clouds and data centers. And the third is all about trust and security and context for AI applications.
So so much to talk about AI deployment modes. So let's take one thing at a time. So we've talked about how in the near future we will still live in a world with multiple data in multiple different places, and then some sort of data movement or either replication or synchronization. But if we look at one single database, I remember in early days of 2000, I think it was Martin Fowler from ThoughtWorks who was very excited about this concept of polyglot persistence. And his whole notion was that if you are doing transactions, absolutely use relational data model. But if you're doing any kind of social network stuff, then use graph database. If you're doing a product catalog, then you use a document database. If you're doing log analysis, use a time series database and on and on. So this polyglot persistence became this hot topic, but now I see more and more databases are becoming multimodal or multi-model. So what are your thoughts on this multimodal concept for databases and how that space is proceeding?
So I think the time you're referring to is perhaps a golden age for a lot of exploration. I think a lot of people tried a bunch of different things. And we should be very fair. I think a part of that driver was the relational database industry, our industry, kind of dropped the ball. We focused on only one kind of use case, right? We were not looking at many of these other use cases. And so naturally, I think we had this efflorescence of different systems and different things coming up. Uh, our take is having too many different versions of the data just for the sake of having it for different data models is not necessarily always the right answer. And in fact, it causes additional complexity. In fact, it causes two kinds of complexity. One, an architectural complexity, where you'll be having to build data pipelines to move data from one system to the other. And a lot of that then ends up uh, causing additional problems. There's cost problems, there's reliability problems. We can all build and babysit data pipelines, but do you want to? I mean, we just talked about the pain of the reason a lot of the zero copy is interesting is because people don't want to make ETL. They don't want to uh,
Yeah.
maintain ETL. If it happens, someone takes care of it for you under the covers. It's one thing. You don't want to be babysitting these systems.
Yeah.
But consistency is also a big issue, right? Not having the data in the same place, not having the right version of the
Yep.
data is a
Correct.
real issue. And the second problem then, when you have too many different data models, is actually one of application complexity, where you have to stitch these different data together. Both, I think, are important problems to address. And uh, across our portfolio, both with Spanner and with AlloyDB, we have been investing heavily in this idea of bringing together multiple different kinds of data models
Hmm.
and helping tame this beast, if you will.
So, if I may ask, what are the different data models that are supported by Spanner, for example?
Perfect. Great question. So Spanner supports full text search,
Hmm.
vector indexing,
Hmm.
and graph. Uh, but you can also run key value workloads in Spanner. You can run a Cassandra workload in Spanner. Uh, we you can also Some people can also run document database workloads in Spanner. So there are more different ways in which you can use Spanner. But maybe I can give an example, even with
Yeah,
something like
that'd
full
be
text
amazing.
search.
Yeah, let's
Uh,
do that.
I'd like to talk about what we did with Gmail, because that's such a
Hmm.
beloved product that so many people use. Uh, about maybe 8, 9 years back, we set out to reimagine Gmail to run on Spanner from a previous proprietary storage system. And there
Hmm.
were many reasons for this. But one of the biggest things was data consistency, having both the storage of the data that is coming in, your emails, your attachments, information, as well as the indexes to be consistent. And there were multiple reasons for this. One was actually a user experience. Imagine if you go and buy something on an online e-commerce website. Uh, Very common thing is you want to go search in your email to see, did I get the receipt? And if search is being served from some other system, where the data is not actually consistent with your email itself, and you get no results, it's actually a real issue. People then get confused. Did the email come? Did the email come, but is Gmail not working? Is it not indexing it and showing me what I've seen? Or is there a problem on the e-commerce website? Should I go and check my order? These are real problems that impact uh, customer experiences. And then there's the challenge of how can I possibly index and access search for data at Gmail's unimaginable scale. And one of the interesting problems is to get not just search for all items that contain a particular keyword, but getting the right ranking, getting the right relevance, and leveraging some of the infrastructure that was there in Google. And for various reasons, Gmail's search index was actually a different system than storage,
Hmm.
causing all of these challenges. So, for instance, when you start searching in Gmail, the look ahead search would give you better quality results. But when you hit enter, you don't get the same order of results. Right? This is something that many people would have noticed. And we set out to fundamentally reimagine this by saying, let's build full text search directly into the storage system itself, and so into the database system itself. Let's leverage Google's technology on doing things like rewriting search queries, not database queries, right? And having it all in a single system that's fully consistent.
Hmm.
And the results have been amazing for us. We've not just fundamentally solved that data consistency problem, the user experience is better, but we also have better outcomes. People see, when you measure it based on click-through rates and things like that, people love the new Gmail experience. But it also, I think, had a big benefit for our application developers who are building the applications, because now they don't need to keep writing for every little feature. You used to have to write a read or write test case. You need to make sure, did the data come, is the data actually consistent? You don't have to worry about any of these problems, right? So full text search was a great example. But the two other examples are vector search,
Hmm.
where we took a proprietary, one of the world's best vector indexing that was built in Google. In fact, for YouTube, you were talking about earlier, it's called Scan, uh, and we embedded
So
inside
scan as in SCANN.
SCANN. I think it stands for
Okay.
Scalable Nearest Neighbor. So
Yeah,
with vector
approximate
index,
nearest neighbor. Yeah.
right? With vector indexing, you're trying to find semantic search, and graph is a particularly interesting journey, because getting back to that, do you have specialized systems or not? For a lot of people in the graph space, as an article of faith used to believe, that in order to get performance, you needed a proprietary storage system. Now, I think it's Fowler's observation is true in the sense of people have partisan experiences, or if I believe I want to address a problem as a graph, I want to model a problem as a graph. Developers love it, and we have to meet developers where they are. And so I think it's very important to provide those experiences. A graph experience, I think, is super valuable. But what we learned is that you don't need to rebuild the database system. You don't need to build a proprietary storage system. In fact, what we learned was having good graph processing was actually a query processing problem and not a storage problem. And that is actually a really important insight, because we could then
Yeah.
build uh, graph technology deeply inside the database engine, uh, provide the right experience without having to rebuild one of the hardest challenges, building scale, building reliability and availability. Right? I always like to say, databases, in the end, we have one job: don't lose your data. That's a really important thing, right?
Yeah.
And not having to
How,
solve it
yeah.
again and again is very,
Yeah.
very
Yeah, you're right, because to be fair, how you store the data should never be the end user's concern, right? I mean,
right.
whether it's stored in purest graph, or it's stored in relational but has graph query engine, supports all the graph primitives, that's more important to the end user, as long as the performance is not uh,
Exactly. Exactly.
impacted.
But then there's this other interesting thing: when you're able to have the system where you can have different ways of looking at the same data, I think more magic is also possible now. We have, in addition to multimodal, which is, I
Hmm.
think, an interesting thing that people have talked about, we have also the game changing ability of interoperability. In other words, I can have that same data, I can have some set of users coming at it from a purely relational view,
Hmm.
can build a graph overlay on it. A graph overlay is essentially a DDL statement. Create
Hmm.
property graph, you define what the nodes and edges are, and then you can start running GQL graph queries on that same data. And so you can now come at the data through multiple ways. You can add a vector index, you can add a full text search index, and even in this, you have the ability to mix and match. So I can have a pure GQL query, which is only operating in graphs, which really appeals to that constituency, right? Who really loves graph as a way to reason about the data. You can have queries that come in on the SQL side. One of the beautiful things that actually happened here was standards bodies work very well together. So as part of the SQL standard, something called SQL PGQ, or SQL Property
Hmm.
Graph Query, came to pass, where
Yeah.
there's a match expression in a SQL query which can operate on a graph defined by this create property graph DDL statement. And this match expression is exactly the same semantically, syntactically, to the query coming in GQL. So now you can have a query with a subquery being a graph. You can include full text search predicates, you can include vector predicates. All of this comes together when you're actually addressing the system. And we also got things that we didn't anticipate, where because we know that there's a graph query, there are certain uh, extra query processing improvements that we're able to do. And in general, it also helped when we focused on making traversals better. Recursive queries started performing better for pure relational workloads too. So one of the other things from my perspective as an engineering leader is that let's just build these systems more economically, because
Yeah.
the investment we make is lifting all boats. So I think and that in the end helps users. People want things
Yeah.
to work well.
Yeah, people want their architectures to not be complex because more complexity means more security issues, more cost, things break down. So this whole simplification. So we talked about like, this whole HTAP, OLTP, OLAP. We talked about multi-model. But then if we move up to the API layer, even there we see consolidation happening. For example, you mentioned that Spanner supports Cassandra applications, and recently Firestore went GA with MongoDB compatibility. Is that correct?
That's correct. That's correct. So Firestore is a serverless multi-tenant database, which
Hmm.
actually leverages Spanner, but just offers another opinionated API surface area uh, built for document databases. And
Hmm.
with the with the MongoDB compatibility API, we can bring the power of open source. Like if I go back to our Agentic Data Cloud mission, the three things was AI native infrastructure, openness, and trust and security. And openness is about open formats. And so things like Cassandra become industry standards, and MongoDB industry standards, Postgres is industry standard, GQL is also one of that. So bringing open data formats, open APIs is also a big part of it, as well as being able to run this infrastructure on any infrastructure, any footprint, data
Yeah.
center, cloud.
So,
I just wanted to add one more thing, Sanjeev,
sure.
on
Yeah.
when you think about connecting data. Uh, so if you look at search as an example, search as a
Hmm.
problem, it's actually a classic case where people historically did keyword search separately,
Hmm.
right? And you had your a corpora of, let's say, if it's an e-commerce website, you might have catalogs. A
Hmm.
catalog would have text, description of items. It would have some categorization. You might have images, and people built fairly complex polyglot search systems over the years where people could go and ask questions on it. One of the interesting things, opportunities that have come up with vector search now is, well, how does the system evolve? Is this still going to be a fairly static system that lets you search through a catalog? Uh, am I now going to combine full text search along with vector search? And here, I want to talk about a partnership with Target.com, whose online
Hmm.
search uses AlloyDB. And one of the interesting things that they realized was it was the search problem was not just a pure search problem. It was a polyglot problem that you had to combine data in relational databases. For instance, your catalog has price information. If you're a sophisticated retailer, your merchandising team may be updating price on a more real-time basis. It has inventory information, which is if you're a logged in user, you might want to see uh, your search results ranked by inventory of the item in the store closest to where you are currently. And you want to have full text search, and you want to have vector search. Now you have, when users ask these questions on the website, the system is essentially translating this into a query that is effectively probing multiple indexes. Now, what happens when each of these are separate systems? If I have a specialized vector system, a specialized full text system, and I have a database where I have inventory and price, a big question is, which index do you probe first? I could go probe the vector index first, and I might get 20 results. And then I go take those 20 results to the database, and I might find when I apply my
Yeah.
next predicates, nothing passes. So
Yeah.
I've not been able to produce any result. If I go probe my database first, I might get too many results, and then I cannot make use of the vector index. So it's a critical challenge when you go build these specialized systems. Connecting them is actually a non-trivial problem. And
Yeah.
so our insight here was, take these different indexes, the data, the objects, the video images can live separately, but take those indexes and put them in a single system. So in AlloyDB, we built filtered vector search. So my query can involve all of these predicates, and we will dynamically, on a per request basis, figure out the right order.
I wrote about Target in the blog I wrote after Google Cloud Next. I was very impressed by where this technology is going. I think the example I gave was that you could upload a picture of a pair of shoes or pants or something like that, and you can ask on Target.com, show me products that are like this. So from my understanding is that you send a picture, that picture gets converted to vector embeddings, then using scan or something, a similarity search takes place on the catalog, and then it shows you the pictures of the names and pictures of the similar items. So
Correct.
this is mixing vector search with traditional search.
That's correct. That's correct. We put them all together, and I
Yeah.
think the message, in some sense, is uh, in a sense, it's you can actually do more than just stitching things together at the application level when you're
Yeah.
able to combine indexes on the fly.
Yeah. Even things that impressed me that I saw in Spanner and some other databases is how AI functions are now embedded into SQL. I remember those days when I had to do sentiment analysis on some text tweets that were coming in. Just doing something like that required some data science background. And now it's simply a single function that you call, and it can give you the analysis of whether it's positive, negative, or neutral sentiment.
That's right. And across our data portfolio, we are doing something, take this to the next level. We
Hmm.
are working on things like proxy models. We have a paper in this year's Sigma conference on it, and we have a blog post I'll share
Hmm.
with you separately, uh,
I-
which let you on the fly, because there's multiple challenges here, right? When I go uh, and include an AI function in the where clause of a query, I'm
yeah.
potentially making a remote RPC call to an AI model for a very large number of rows. So there's a bunch of engineering work that we did to do things like batching, but even interesting tricks where we're able to uh, make a single LLM call instead of multiple LLM calls, where you then benefit from the natural caching that happens in LLMs.
Hmm.
So there's a very interesting set of work that we've done to make that more efficient. But then we also have this idea of a proxy model where, under the right circumstance, we can build a local model that train it on the fly, maybe for the first set of rows, and then actually substantially reduce your token costs and your latency, because not every request, these sentiment analysis, for example, not every request needs to have the full power of an LLM. And so this part about AI functions is actually really interesting, because it not just makes it available directly in the database, it also potentially reduces costs and latencies in a very big way.
So instead of making a remote call to an LLM, incurring the round trip time, the LLM cost. So I love the idea of caching. But are you embedding a small language model inside Spanner now that can be trained or fine-tuned to my needs?
So this is think of it as a proxy model. We have it right now in AlloyDB and in BigQuery, actually.
Hmm.
But yeah, the basic idea uh, is in, in the different things make sense based on what you're trying to do. If your application is only looking up a very small number of rows,
Yeah.
which is often the case in a transactional database, you might not see that much benefit. But if I have a
Yeah.
bit of an analytics query I'm running across a lot of data, then you would see a lot more benefit, right? So that is
Agreed.
the core intuition. And so you can activate this
Yeah.
proxy model in a few different ways. You can run it for the first 1,000 rows. If I
Hmm.
have 1 billion rows, for example, I can activate it by prepared statement. So I create that prepared statement one time, and then I can keep using multiple different bind parameters, and each time activate that same model. So the way it gets used, the way it gets uh, exposed may be different, but the core
Yeah.
idea is, can I come up with a good approximate proxy model? I would not use the word caching specifically. I think I would just call it this proxy model.
Proxy model. So we've talked quite a bit about how AI is getting so deeply embedded inside our databases. I want to take us up to more of an architectural macro level. What is the role of operation databases in the world of agents? And where I'm going is that, first of all, in a multi-agent an agent may be doing a lot of experiments, chain of thoughts. Each one is generating some data. It's deciding which is the next best action. So there's a lot of trajectory data that is being created
Right.
that has to be maintained for audit reasons. So there's a whole memory, short-term memory, episodic memory. What is the role of operational database?
I think it's a great question, and perhaps it's a question of our times. Uh, it doesn't matter whether you are a token purveyor, like a frontier model. Anthropic is a good example, or a token consumer. Uh, I think there's a huge role, for databases. So, for example, Anthropic talked in Google Cloud Next about how they use Bigtable to store conversations and prompts, and they use
Hmm.
many of our other systems that we'll talk about at some other time. But in general, I think there is this super valuable aspect of storing prompts, trajectories, and other piece of information, where at some level these are humble
Hmm.
databases doing what we've always done, right? Not losing your data, being able to provide fine-grained access, supporting low latency, and all of that. Now, I think things like full text search, vector indexing, are particularly interesting in this space because you're storing unstructured data and not just structured data. So that's, I think, a very key aspect of many of these things. Trajectories have some structure, but they typically, the input of a tool is a piece of text or maybe a JSON object. And so all of these things that we've been building pre-AI, whether it's document in database technology, like how do I store and index a JSON object, or full text search that we talked about, or even graph, they all, I think, come to fore, right? So this is one piece of where the database fits in. The second piece is, I think, the very nature of what an application is something that we are going to see interrogated again. Uh, in the OLTP database world, we used to talk about decoupling compute and storage, and a big reason for that was that the lifetimes of compute and storage were different. Compute instances would come and go because of failures and scaling out and scaling in. But through the last 50 years, applications have a codependent relationship with the database, and they
Hmm.
were always tightly coupled. And
Yep.
so, as a manager at Google, for instance, there are about 10 different systems I
Hmm.
end up using on an almost daily basis, all of which have a separate copy of an employee, their name and level, and when they join, an employee ID. So there is no universal store of that transactional data. It's all tied to the application. Now, I think we're seeing a world where the future of an application could change. Application today has four walls. It has boundaries, a defined API surface area, user experience. But I think what we're going to start seeing is applications that are more ephemeral, workflows. A user decides to combine two different systems on the fly, and the AI model is happy to oblige, spins up some code on the fly, connects these things, and executes maybe what we'd call a workflow. In the before times, you might call a systems integrator, an SI, to come and
Yep.
implement a
Yeah.
custom
Agree.
integration.
Agree.
Right now, where is that going to be stored? So these are not necessarily the trajectories inside the model,
Yeah,
but the trajectories of
absolutely.
workflows, which are also important storage problems, right? So I think a whole,
Mm.
interesting evolution here happens where you want to store these pieces of trajectories, where the if the application's lifetime is now different from that of the data, what is the new decoupling that we're going to see? So I think it's I
Yeah,
think really interesting piece of the future of the application. And then there's a third thing, which is I have existing applications, but I have always, like me and my team, my feature backlog is much
yeah,
bigger than the resources have to go implement features. And so I think we're going to very dramatically see people building agentic side experiences for their applications.
yeah.
It'll
So,
probably start with bespoke
yeah.
applications first.
So, Sailesh, this is where I see the world moving. So, in my organization, let's say I work for a large multinational, I have hundreds of SaaS tools. And I'm in marketing department. I have all kinds of marketing SaaS products, but I want to run a campaign. And what I need is a very custom. So I know the workflow because that's what I do. I'm in marketing. I have a workflow. So I write code or I use some coding agent. Google has anti-gravity. So I use some of that and I write my application. All I need is secure and govern access to my data. That's it. I can create, and this is not SaaS apocalypse because
Right.
no one's going to get rid of those SaaS tools. They're
Exactly.
enterprise class with all kinds of bells and whistles. But my job is done. But you're right. I didn't think about it till you just mentioned that workflow. Whatever I did needs to be stored in a database for posterity. If somebody comes to me, or maybe I may turn it into a skill and reuse
Right.
it.
Yes.
So
Yes.
then the
And I
question
may
is,
want to
yeah,
unravel it. I want to audit it. All the problems that we've
yep,
historically had to solve are still
correct.
there.
So then the question I have for you is if in this scenario, if I want to turn it into a skill, where would I store it? Is Spanner the right choice? Is it how will that take place?
If we step aside for a second,
Okay.
I would assert that all databases have to get really good at offering very low footprint access in cost, in latencies. And it's for a variety of reasons. One is what you said, the citizen developer, perhaps who's not even using anti-gravity, they may be using something like
Yeah.
uh, AI Studio. Google DeepMind has something called AI Studio,
Hmm.
where a person who's never built an application can start generating an application.
Hmm.
You could have uh, anti-gravity might be a more of a skilled software engineer, right?
Hmm.
Who's building something. And so we have multiple ways of addressing this. We announced the AI developer edition for
Hmm.
CloudSQL and Firestore. So both of them are recommended options within AI Studio, GDM's Google DeepMind's AI Studio. Uh, and so they are certainly viable options in large part because you want scale, you want cost, you want something very cheap. Uh, the same is true, even can be done with Spanner too. I think in general, what
Yep.
we are seeing is the importance of provisioning a database, importance of having a very low cost footprint. They are important across the board. I think an
Yeah.
interesting question is, in a world where an AI model decides what database to use, I think it's interesting to go back to where earlier part of the conversation where you have opinionated software engineers picking the data model, and now you have an AI model which is actually going to say, maybe I need a relational system, maybe I need a non-relational system,
Yeah.
maybe I need a scale-out system. And I think that'll influence what needs
So,
to happen,
yeah.
and that's why we want to have this functionality across our portfolio.
So having this functionality across portfolio leads me to two very critical topics on my mind, and we're getting so close to end of our podcast. So let me just lay it out here. One is if I am going to have this so much power in citizen developers' hands, I need consistency, and that consistency is coming through a context layer. because I need a common definition of what is a customer, what's a campaign, how am I measuring its effectiveness? Because if three different people in marketing vibe code and have three different definitions, the whole thing fails. So I need a common context. And so my question to you is, where is that context? And the second thing where we would end our thing is deployment. Where is my database deployed? Because a lot of training and work is also happening on-prem. So this Spanner Omni, which was announced. So let's tackle context and Spanner Omni. So what are your thoughts?
I'll do the contexting very quickly, and
Okay.
then we can spend a little bit more time on Omni. Our answer is the knowledge catalog as part of the
Hmm.
Agentic Data Cloud. I think this is very quickly evolved from in the pre-AI. The basic idea was around governance, about getting all
Hmm.
the metadata of all your systems. And we've deeply integrated all our operational databases. The metadata, you make a schema change in near real time, that schema is actually reflected in
Hmm.
the knowledge catalog, which is an evolution of our earlier Dataplex service. But what's really, I think, interesting is this knowledge catalog is serving as a foundation for adding much more context than metadata. Very simple example I like to give: you have a database table with two columns, a billing address and a shipping address. Now, if one of them is null, maybe there's an implicit piece of context that billing address is the same as shipping address, but
Yeah.
that's not just there in the schema. So
Yep.
we build the context engineering tools to go,
Hmm.
make the context, the knowledge catalog have
Yeah,
more
it's a good
information.
example.
And I think it's very interesting. You could imagine
Hmm.
a AI model looking at your existing application code. If you see a coalesce expression, you could probably guess that this is the right thing. And then we have tools to build AI agents, tools to build custom agents on your operational database that are able to use this particular context. And then there are other interesting challenges around security and privacy, especially for operational databases. But perhaps in the interest of time, I'll switch to the Omni conversation. Um, so with Spanner Omni, so first we've ahead perhaps of other people in the industry, recognized even before Spanner Omni the importance of people running on different kinds of infrastructure. Not everyone is going to run in a hyperscaler environment. Now, it's even more true today with AI models, but this is, I think, always been the case. I frequently talk to CIOs who talk about their crown jewels remaining on premises in their data centers. And so we built AlloyDB Omni, which is giving the performance of AlloyDB, all of the the columnar improvements, the analytics improvements, the vector indexing improvements running on your on-premises piece.
Yeah.
But a couple of years back, we set out to go address this problem for Spanner for many reasons. Some of it is what you laid out. Some of it is stressed exit concerns, regulatory concerns. Sometimes people are using Cloud Spanner, but for business continuity, they want that data to be available in their data center. And so
Hmm.
we are very excited about Spanner Omni. We launched it in April in Google Cloud Next. You have the power of Spanner in any deployment scenario that you want. You can run it on your own data center. You can run it in Google Cloud in using Google GCE or GKE. You can also run it in AWS, and we'll have Azure support coming very soon. We'll be GAing very soon,
Yeah.
probably in a month or so.
It's interesting how one word we have not used at all, and the word that I used to associate with Spanner, the very first time I heard about it is distributed, because
Right.
it's a globally distributed database without this whole sharding thing. It's just multi-write enabled, multi-read, and obviously, but multi-write. So timing becomes really critical. And so we always thought that Spanner can only run in Google Cloud because it uses its GPS-based atomic clocks to keep the time in sync.
Right.
But but you have now replicated through a logical clock, and as a result, Spanner can now run anywhere in any other cloud provider eventually and on-prem.
That's correct. So we have what we call software through time. Um, and people often ask, this question of how this is working. We thought you needed, Google's infrastructure, right?
Mm-hmm.
So the answer is a bit nuanced. First, I'll say uh, Google's own atomic clocks have come a long way, right, to make Google's true time work. But Spanner was designed back in 2012 before the atomic clocks were as good as they are now.
Mm-hmm.
So, in a sense, Spanner's original design was for a more demanding environment, and so software true time is roughly as good as what that environment was a while back, right, inside Google. So for many use cases in practice, even if we are just using software-based true time, uh, even multi-regional use cases, the epsilon, the time delta is good enough that for most applications, I think they will not necessarily notice the difference. There are some more corner cases where it will be more noticeable, but by and large, we think most people will be excited. Now, we've also heard customers who come and tell us that, hey, we have proprietary data center environment. Can we put in atomic clocks for you to leverage? And the answer, certainly, and we are very happy to try to figure that out in participation with customers. The so yes, I think we've taken the power of true time that was there in Google, which was only possible in the past with Google's atomic clocks, and we've made this now available on a more commodity infrastructure.
That
Now,
is,
you said something also I just wanted to add. You talked
yeah.
about distribution. I think it's interesting. Spanner in sometimes is a bit of a Rorschach test. People take of it what they want, and it has many different interesting technologies. It has sharding and scale out. It has sharding and scale out built with transactional support. This is why you have global secondary indexes fully consistent. You have distribution across regions. And so all of these things come together. Not every customer wants all of them, but certain key attributes become very important. And now what we're excited about is we can get that power, which you thought you could only get in the cloud world, to people's data center deployments and in other hyperscalers.
Very exciting. I am literally blown away by how much advancements are taking place on the operational side because analytical side we hear ad nauseum about Apache Iceberg and Delta and all these things, and but operational side is the bread and butter of an organization, and I'm so happy to see you share all these developments, and I want to thank you for educating us on the world of operational databases and where Google is taking them next.
Thank you so much, Sanjeev. It's always been a pleasure to talk to you, and I think I learn as much from you.
Great. Thank you everyone for joining. Until next time, see you. Bye.